Session 5.5, double angle. We do have the double angle identities. For the cosine 2a, we do have a 3 different formula. Okay, cosine 2a, it can be equal to cosine square a minus sine square a, or 1 minus 2 sine square a, or 2 cosine square a minus 1. Okay, I need you guys remember all the double angle identities. And then sine 2a, we only have a one formula, that's a 2 sine a cosine a. And then tangent 2a, that will be equal to 2 tangent a over 1 minus tangent square a. Okay, one more time, I need you guys remember all the double angle identities. Now, we're going to try to prove it like one by one. So first, we can use the cosine sum identity to divide double angle identities for cosine. Okay, this is what we want to prove. Cosine 2a equal to cosine square a minus sine square a. So we're going to start with the left-hand side, cosine 2a. I could break it down to a plus a, right? Now, I'm going to use the cosine sum identity. That will be cosine a minus sine a sine a. Okay, cosine a times cosine a, which is going to be cosine square a, minus sine a times sine a, sine square a. Okay, we just proved the double angle identities. So this is going to be your formula. Okay, and then cosine 2a, we do have a free formula. We only prove one of them. So the second one, since we already proved this is true, so we're going to start from here. And then, remember this identity, sine square a plus cosine square a equal to 1. And then we want to get out of sine square a. So sine square a, that will be equal to 1 minus cosine square a. Okay, I use this identity for here. Now, I'm going to distribute the negative. So I will have cosine square a minus 1 plus cosine square a. So combine the 9 terms. 2 cosine square a minus 1. Okay, another identity. Do the same thing for this one. Cosine 2a equal to 1 minus 2 sine square a. Use the same identity. Okay, we're going to start from here. So this time, I want to get out of cosine square a. Cosine square a will be equal to 1 minus sine square a. Combine the 9 terms. You should get this one. Cosine 2a equal to 1 minus 2 sine square a. So another identity. Okay, how about sine 2a equal to 2 sine a cosine a? We can use the sine sum identity. So left-hand side equal to sine 2a, and then we're going to break it down a plus a here. Apply the sine sum identity. Okay, you're going to get sine a cosine a plus cosine a sine a. So add it up, that will be 2 sine a cosine a. So another identity. Okay, how about the tangent 2a? We can use the tangent sum identity. So tangent 2a, that will be equal to tangent a plus a. And then apply the tangent sum identity. So that will be tangent a plus tangent b over 1 minus tangent a tangent b. Okay, combine the 9 terms, that will become 2 tangent a. And this one, tangent a times tangent a, which is going to be 1 minus tangent square a. So another identity. Okay, example 1. Given cosine theta equal to 3/5 and sine theta less than 0. So sine theta less than 0, it has to be on quadrant 3 or quadrant 4. And then find sine 2 theta, cosine 2 theta, and tangent 2 theta. So to find the sine 2 theta, we must first find the value of the sine. Okay, so we're going to use the identity. We already know about the cosine. We plug it in here, find out what is the sine theta. So sine squared theta equal to 1 minus 9/25. Get the same denominator. Take the square root. Okay, you will have a plus minus here, but we already know sine theta is less than 0. So I only pick the negative one. Okay, now we can use the double angle identity for the sine. So sine 2 theta equal to 2 sine theta cosine theta. We already know about the cosine theta and we find the sine theta here already. So plug it in. So you should get 24/25 negative. And then we want to find the cosine 2 theta. Okay, we do have a free formula for the cosine 2 theta. Okay, you can use this one because we found out the sine squared theta from the part A already. Okay, plug it in. So you should get negative 7/25. Okay, tangent 2 theta. So we have the formula 2 tangent theta over 1 minus tangent squared theta. Okay, you do have a two method to find out the tangent 2 theta. The first one, I would find out what is my tangent theta. Okay, tangent theta equal to sine theta over cosine theta. I find it out from the part A already. So simplify it, you're gonna get negative 4/3. Then I could plug into this formula. Simplify it, you should get 24/7. Or that's another method. Tangent 2 theta will be equal to sine 2 theta over cosine 2 theta. And then we already find it out what is a sine 2 theta and what is cosine 2 theta. We could plug it in. Simplify it, you're gonna get 24/7. That's the same idea. Example 2. Find the values of the 6 trigonometric functions of theta if cosine 2 theta equal to 4/5 and the theta is in between 90 to 180. So that will be in quadrant 2. Okay, so cosine 2 theta, we do have the formula equal to 1 minus 2 sine squared theta. So we could plug it in, cosine 2 theta equal to 4/5. Combine the like terms. And then we're gonna take the square root. For the sine in the quadrant 2, theta will be positive. Sine theta in the quadrant 2 will be positive. So we do have 1/10. And then we try to rationalize. So we're gonna times 10 over 10. Sine theta, that will be equal to 10/10. Okay, right? The first answer. We need to find the 6 trigonometric functions. Okay, so sine theta equal to 1 over square root of 10. I try to graph the picture here. And then we're gonna figure out what is my x here. So plug it in. You should get x equal to -3 since this is in quadrant 2. So x is equal to -3 here. So cosine theta, that will be -3 over rectan. Rationalize. So you should get -3 rectan over 10. And then tangent. Tangent will be equal to opposite over adjacent. So it's going to be -1 over 3. Cotangent, that will be reciprocal of this guy. So secant theta, that will be reciprocal of cosine. And keep in mind, don't try to reciprocal of this one. If reciprocal of this guy, we need to rationalize one more time. So I will find the reciprocal of this one, which is gonna be rectan over -3. And then cosecant, I will use the reciprocal of this guy. So that will be rectan. Example 3. Verify that cotangent x sine 2x equal to 1 plus cosine 2x is an identity. So I'm gonna start with my left hand side here. And then I have a cotangent on the left hand side, and then right hand side I do have a cosine. So I try to convert it with the cosine side, which is gonna be cosine x over sine x. And then I'm gonna use the double angle identity. For the sine 2x, sine 2x will be equal to 2 sine x cosine x. Simplify it, okay, cos out the sine x. I will have a 2 cosine square x here. And then 2 cosine square x, we could apply the formula, right? Cosine 2x equal to 2 cosine square x minus 1. So we have this guy here. So that will become cosine 2x plus 1. And that will be equal to your right hand side. Okay, example 4, simplify each expressions. So I do have a cosine squared 7x minus sine squared 7x. Do you guys recall any formula? The double angle formula for cosine, right? So this is going to be your A will be equal to 7x. So that will be equal to cosine 2 times 7x, which is going to be cosine 14x here. And then B, sine 15 degree, cosine 15 degree. Okay, they do have the same angle. It looks like similar to the double angle formula for the sine, right? However, we need the 2. If we have a 2 sine A cosine A, that will be equal to sine 2A. So we're going to make it up. Okay, we're going to do 1/2 times 2 here. So you cancel out, we didn't change anything. And then I'm going to group this guy together. 2 sine 15 cosine 15. So your A will be equal to 15. So that will be equal to sine 2A. Which is going to be sine 30 degree. Sine 30 degree, that will be equal to 1/2. So you're going to get 1/4. Okay, example 5. Write sine 3x in terms of sine x. So we're going to break it down, the 3x equal to 2x plus x here. And then we're going to use the sine sum identity. Try. Okay, check your work. And then we're gonna break it down one by one because we only want to in terms of a sine x. So sine 2x, double angle formula, that will be 2 sine x cosine x. For the cosine 2x, I would use cosine square x minus sine square x. Now, combine the like terms. So I have a 2 sine x cosine square x here. And this one, I'm gonna distribute the sine x for both of them. So I have a 2 sine x cosine square x plus cosine square x sine x. So this is the like terms. Okay, remember the multiplication? I could switch the order here. So this is exactly the same thing. So 2 plus 1, I'm gonna get 3. And then I need to get out of cosine square x. I will be use the identity. Cosine square theta equal to 1 minus sine square theta. So plug it in here. And then we're gonna distribute it like 1 by 1. So combine the like terms here. I'm gonna get 4 of them here. So my final answer is only in terms of the sine x. Okay, product to sum identities. We can add the identities for cosine a plus b and cosine a minus b to divide a product to sum identities for cosine. Okay, let's look at it. We do have the sum identities for cosine and difference identity for cosine. And then we try to add it up together. Okay, add up these two formula. When you add it up, we cancel out the sine A and sine B. So I left with this guy. Okay, cosine A plus B plus cosine A minus B. This is exactly the same thing. So 2 cosine A cosine B. And then I'm going to divide it by 2 for both sides. Okay, divided by 2. So you're going to get the product to sum identity. Cosine A cosine B equal to 1/2. The whole thing, okay? The 1/2 is applied for the whole thing here. So I put the bracket. So this is going to be the first formula for product to sum identity. And then we're going to do the subtraction for the cosine A plus B and the cosine A minus B. Okay, subtract it. When you subtract it, these two guys will be cancelled. So I left with cosine A minus B minus cosine A plus B equal to negative, negative become positive. So I have a 2 sine A sine B. And then we're going to divide it by 2 for both sides again. So we do have another formula. The product to sum identity. So I do have another formula. So this is a product to the difference identity. Okay, another one, we will add the identity for the sine A plus B and the sine A minus B together. Okay, we're going to add it up. So these two will be cancelled out. And then we're going to divide it by 2 for both sides. Okay, now we're going to do the subtraction for the sine A plus B and the sine A minus B. Okay, we subtract it together. So these two guys will be cancelled out. And this is going to be negative, negative become positive. Okay, divided by 2 for both sides. So we do have the 4 product to sum identities. Again, you guys need to remember it. That's a lot formula, right? Okay, example 6. Write 4 cosine 75 degrees, sine 25 degrees has the sum or difference of 2 functions. So we do have a product to the sum identities here. And then this one will be have the cosine and the sine, cosine and the sine. Okay, so cosine 75, sine 25, we could plug into this formula. And then we're going to keep the 4 outside here. Okay, 75 plus 25, that will be equal to 100. And this is going to be equal to 50. Okay, 4 times 1/2, which is going to be equal to 2. I distribute the 2 as well. We do have a product to sum identity, and we also have the sum to product identities. So we do have a 4 formula again. Okay, example 7. Write sine 2 theta minus sine 4 theta has a product of 2 functions. So we're going to think about like this part here. Okay, sine 2 theta minus sine 4 theta. Okay, you're going to use this formula, the second one. All right, 2 cosine a plus b over 2 sine a minus b over 2. Simplify it. So sine negative theta, that will be equal to negative sine theta. So we do have a negative 2 cosine 5 theta sine theta. That's it.